9702 February March 2022 paper 1 variant 2. The topic is DC circuit, question number 31. In the circuit shown, the lamp P is rated 250 volt, 50 watt, right? 50 watt, and the lamp Q is rated 250 volt and 200 watt. The two lamps are connected in series to a 250 volt power supply. So there is a power supply, there is a switch connected in series, right? P and Q. Assume that the air resistance of each lamp remain constant. So this is the most important point. The resistance, either it is the both are connected or not, the resistance is fixed, no change. So, which statement is most accurately describe what happens when the switch is closed? So, if you could see the options, lamp P emits four times as much as power as lamp Q emits twice as much power as lamp Q. So, it is actually need some calculation to come up with the true statement, right? So, what is given to us? We have given to us the potential difference, power rating, and the resistance is constant. So we need a formula that contain power, potential difference, and resistance. So we have this formula: P equals V square R, or P equals V square R. So we have this formula. So in this circuit, first we need to find out the resistance which is fixed. What is that? So we need to find out the resistance. So as it says, it's constant. So we see 250 and 50 watt. So V square over R means 250 square over 50, and for Q is 250 square over 200. What we will get? The lamp P, the resistance of lamp P is 1250 volt, and the resistance of lamp Q is 312.5 ohm. Sorry, I said wrongly. It's ohm. 1250 ohm is the resistance of lamp P, and 312.5 is the resistance of lamp Q. Right? So we got that. Okay. So we got the resistance. Now resolve the circuit. Right? We have the resistance what? 1250 ohm. We know the V1250 ohm, and for Q is 312.5 ohm, right? So first what we will do, we will find out the resistance is, if this is the resistance, right? 1250 ohm and 312.5 ohm. So if we compare these two resistance of P, right, is 1250, resistance of Q is 312. If we just divide this 1250 with 312.5, we will get what? We will get 4. So that means the ratio of the resistance is, if the resistance is 4 is to 1, the resistance of P is 4 times greater than the resistance of Q. Resistance of P is 4 times greater than resistance of Q. And we know the potential difference is directly proportional to the resistance. That means potential difference of P is greater than the potential difference of Q. Potential difference of P is greater than the potential difference of Q. Now, we need to distribute 250 volt with P and Q with this ratio. With this ratio. So first of all, 4 plus 1, 5. So if we divide 250 with 5, we will get 50. So each ratio will be 50. So that means, if according to this relationship, if Q got 50 volt, so it's 4 times 200 will be between P, right? So 200 volt of potential difference of P, and 50 volt is the potential difference of Q. Got it? So 4 is to 1 is like this. Now, again, we have 200 volt and we have 1250. So V square over 1250, we will get v square, means 200 square, 200, the square of 200, the square of 200, the square of 200 divided by 1250 will be 32 watt, and the square of 50 divided by 312.5 will be 8 watt. So 8 and 32. Again, if we divide P with Q, we will get what? 4. So that means P, the power of P is 4 times greater than Q. The power of P, 32 over 8, 4, means power of P, bulb P, lamp P is 4 times greater than lamp Q. So option A is correct.